Hi everyone, so now we will talk about the problem minimum steps to 1, and we have already discussed the approach along with the dry run. So I'm just going to implement the code. The first would be my top down approach and second would be my bottom approach. So let me say, okay, I want to write a function int minimum steps which accepts the value of n, and it should return how many steps it will take to make this number as 1, and it's given you from n. You can go to n by 3, or you can go to n by 2, or you can go to n minus 1. So let's think about the base case, and let's also think about the recursive case, right? So first we will write recursion, then we will make it as a top down DP problem. So base case would be that if you have already reached 1, right, the smallest possible value of n, that is 1, then it will take 0 steps to make it as 1, right? So if the number is already 1, you do not need to do anything, so you will just return 0. In the recursive case, as I said, you have 3 options, right? So let's say the first option would be to okay, let me say you have 3 options, option 2 and option 3, and all of the 3 options are not valid for every value of n, because if n is not divisible by 3, you will not have option 1, right? So let me say by default these options are going to store int max. Okay, int max goes in the header file called climits, which means a very large value, and we have seen the recurrence is going to be minimum of the 3 options, right? So first option, if n is divisible by 3, then you can say, okay, I can compute option 1 by making a call on min steps, and here I give n by 3. So let's also include the DP array that we would be using, and let me give the DP array, right? If n is divisible by 2, I can update my option 2 as min steps n by 2 and the DP array. Otherwise my option 3 always would be min steps of n minus 1, and I give the DP array, right? So my final answer, right, my answer is going to be minimum of option 1, option 2 and option 3. So min function takes 2 arguments, so in order to take minimum of 3 numbers, I need to have this plus 1, right? Whatever it is, I need to take plus 1, or even okay, I will just do a plus 1 here and I can remove this plus 1, right? So my final answer is going to be answer. So this is going to be DP of. So this is going to be the top down approach, and let me just again explain what we have done here and see out minimum steps of n given the DP array, and let's make a DP array and it's going to be 0. And also we also need to look up if a particular state is already computed. Look up if n is already computed. So if DP of n is not equal to 0, which means there is some value lying in the DP of n, we will just return DP of n. So this makes this recursive solution as a top down DP problem, and this is the compute if DP of n is not known, right? Basically for the first time you will compute and store your answer, right? So let us dry run for, let's say, n equals to 10. Let's say n is 10, right? Then you have 3 options. Option 1 is infinity, option 2 is infinity, option 3 is also infinity, but n is divisible by 2. This case won't execute, so no call from here. And since n is divisible by 2, so you will make a call on DP of 5. You will ask, okay, how many steps you would need to make 5 as 1, right? So this is going to be a call on n equals to 5, and here you are going to make a call on n equals to 9. 5 will make a call on 4, and 4 will make a call on 2, it will make a call on 3, it will make a call on 1, it will make a call on 1, it will make a call on 1, it will make a call on 2, it will make a call on 1 and 1, and 9 will make a call on 8 and so on. It will also make a call on 3 and it will make a call on 1 and 2 and so on, right? But we know the smallest path is going to be this path from 10, 9, 3 and 1. So this one is going to return 0 because to make 1 as 1 you need 0 steps, and this 3 is going to return 1 because you took 1 step here. So this option would be, okay, so this option for 3, because 3 is divisible by 3, so this answer is 0 plus 1, 1. So this 3 is going to return 1. So you need 1 step to make 3 as 1, right? Let me just erase this. Yeah, so this 1 is going to return 0, this 3 is going to return 1, and this 9 made a call on 3, right? So this 9 will say, okay, my answer is going to be 2. And similarly 5 is going to have some answer, which is going to be from 5 you go to 3 and 1, so it returns 0, it returns a 1, it returns a 2, and 5 returns a 3, right? So but you are taking a minimum of all possible options. So at n equal to 10 you take a minimum of infinity, 3 and 2, and you say okay, the final answer is going to be 3. So you can say okay, there are 3 steps, from 10 you go to 9, from here you go to 3, and from here you go to 1. So the final answer is going to be 3, right? So this is how we have actually executed this code. So from every state you are going on the all possible sub problems, and you are getting the answers from some problems using this recursive function call, and you take the minimum. And if some state is already computed, for example 3 is already computed here, so you won't be computing this 3 again, right? So since it has overlapping sub problems and we are able to use the memoization thing, so the complexity would be order of n, because from 0 to 10 here you won't be computing any state more than once, right? So this can be done in, this is done in order n time, right? But if you use recursion, it would again turn out to be exponential. So let us build the code and let us run it and say okay, minimum steps for, let's say n equals to 10, right? It says 3 steps. Let's say n equals to 5, it says again 3 steps. From 5 you go to 4, from 4 you go to 2, and then you go to 1. It takes 3 steps, right? Okay, so in the next part we will cover up the bottom up approach for the same.